So have you guys gone over the kind of pictorial representation of the permutation groups? Lucy, have you guys gone over that in class?
I don't think so, but maybe he did. I don't know if I was paying attention at that point.
Okay, it happens. So okay. Well, what different transformations can I do on this? That would keep it looking like essentially the same triangle. There's fundamentally only two of them. Anyone. Yes, Justin, rotation is one of them. So if I were to do 120 degrees rotation, that would give me 3, 1, 2, right? So this guy right here is one possible rotation, and if I do the same thing, I would get 2, 3, 1. And then what's the one other translation or transfer kind of basic transformation I could do on this? I could flip it. So if I were to flip it down this line, I would get 1, 3, 2. Right? So between these two things, I can get any organization of 1. I can reorder these so I can do 3, 2, 1. I can do, what is the 1 remaining? I can do 2, 1, 3. Via either doing the flip on this guy or the rotation on these guys. So the dihedral group on the triangle is going to be the same thing as S6, right? Or sorry, as S3. Correct? Yes, cool. So someone, no, it's fine. I'll switch over to the stop share. And then okay, someone tell me permutation notation for this. Who do I want? Marius, tell me the permutation notation for this.
Do you mean the cycles?
Yeah,
or?
sorry, the cycle notation.
Okay, so 1 is going to 4, 4 to 3. So 1, 4, 3, or 1, yeah, 1, 4, 3 is one cycle. Then 2 is going to 6, 6 to 8. Then 2, 6, 8, 7. Yes, and then the last one, 3, 4, 5, 5 to 9, 5, 9.
Awesome. Yep. Does this make sense to everybody? Cool. So if I were to give you guys one. Someone reconstruct this for me off of this. Alternate between the two notations. Michael, reconstruct this for me off of this. Michael. Okay. What is the difference between the group action of permutations on some n polygons and the shapes dihedral group? I'm pretty sure that the dihedral group is going to be, so the dihedral group should be a subset of the permutation group, but there are certain things that you're like not going to be able to get when we're dealing with bigger ones. So if I have like 1, 2, 3, 4, 5, 6, 7, 8. If I have this octagon right here, this very, very pretty octagon, I'm never going to have 6 next to 2, right? So there are restrictions on that, but cool. Someone reconstruct this guy for me. Lucy, can you reconstruct it for me?
Sure. So 1 is going to go to 5. And then 2 is going to go to 4. 3 is going to go to 2, I think. 4 is going to go to 3. 5 goes to 6. 6 goes to 1. 7 goes to 9, right? It's just a little crushed in the corner there. And then 8 goes to 7 and 9 goes to 8, right?
No, there's no 8 there.
Oh, that just says 7, 9, and that's it?
Yeah.
Okay, so 8 goes to 8, and then 9 would go to 7.
Okay, cool. I actually started off writing 8, and then I realized that I wanted to make sure that there was some element that mapped to itself, and then proceeded to scribble it out. So cool, and thank you. So you guys seem to understand this pretty well. I don't know if that's selection bias of the 7 people who actually showed up, but the other recitation instructor told me that his students were having a fair number of issues with this. So I figured that this would have been a bigger problem than it seems to be for you guys. Does anyone have any other questions on this?
Yeah, I had a question. I think on slide number 10, there was one example, and I'm not sure if it is correct.
This guy right here?
Yes.
Okay.
So I think it should be like 2, 4, 1, 5, 3. That composition of 3, 4, 5, and 1, 2, 3.
So you're saying, so let's actually just do the full thing to see kind of as clearly as possible. So we go from 1, 2, 3, 4, 5, and then we would use G. So G would map 1 to 2, 2 to 3, 3 to 1, 4 to 4, and 5 to 5, right? And then we would do F, and then we would look, where does F compose to? F composes 2 to 2, composes 3 to 4. It composes 1 to 1. Sorry, you guys can't actually see my mouse here, can you? I always forget that. So 4 goes to 5, and 5 goes to 3. So, okay, you can see my mouse, good. So yeah, sorry, that's getting confused with my other tutoring when I'm annotating on their screen. So here we would say, what does 1 go to? 1 goes to 2, 2 goes to 4, 4 goes to 5, 5 goes to 3. Does that make sense?
Oh, okay, yeah. I thought we were only reading the last row, right? So that would mean 1, 5, 3, 2, 4.
Okay, yeah. No, we go, because what we ultimately care about is, like, if we want to think of G composed of F, we can basically get rid of this line right here. And we're basically constructing it off of this permutation that's left between the first and the third rows.
Okay.
Do people have other questions on this? Cool. Justin's the only one taking advantage of that chat option. Okay. Yeah, I had stuff that I was going to go over here, but honestly, it seems like that would be redundant, considering you guys seem to understand that pretty much fine. And what was this? Oh yeah. Did you guys go over what these U's are? Does someone know what U5 is?
Isn't it unit 5?
Yeah, so it's the kind of divisions on the unit circle that make up a fifth of the way around it. So, and I want to cover this because they were not defined at any point in my undergrad abstract course, so I wasn't sure if, I mean, I kind of figured that you would have, but so it's, if you go over the unit circle and you have the, what is e to the I pi over n, k pi over n. Anything that looks like this is an element of un. So you basically will just get back to the first and your last one are both going to basically be the same point of just one. Cool. Yeah. Does anyone have any questions on anything else in here? No? So have you guys had class so far today? Not yet, right?
Not yet.
Cool. How did you guys feel about your first session on isomorphisms? Or first 2 sessions on it? Cool. So somebody give me two different, give me a group that is isomorphic to Z8. Okay. So Justin, not any reordering, not any renaming of the elements. Actually, yeah, I suppose you can just do any renaming of the elements. Like if you just want to call 1, 2, you can do that. But we can do a more interesting isomorphism from Z8 to Z8. What would that map be? I think there's a few, but you can specify it by how you map a single element, and that'll tell you. Yeah. So Justin is saying we have 1, 2, 3, 4, 0, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. And if you had just renamed, say, 3 and 2, but had 3 operate the same exact way as 2, is that what you're saying, Justin? Like if this is the normal Z8 Cayley table, you could just create the exact same thing, but rename elements, or maybe do A, B, C, D, E, F, G. Okay, yeah. So if we were to change that to what? Star A, B, C, D, E, F, A, B, C, D, E, F, G, H, A, B, F, G, H. You could do it such that A acts like, so just phi of A is equal to 0, phi of B is equal to 1, etc. But there's a non-trivial isomorphism from Z8 to Z8. Can someone tell me what I would map phi of 1 to get that? There's a few different options here. Yeah. Phi of 1 equals 3. I could also, so I'll call this phi 1 I could also have phi2 of 1 is equal to 5, or phi3 of 1 is equal to 7. All of these would give non-trivial isomorphisms from Z8 to Z8. Basically, I can map any generator of the group to any other generator of the group, and that's going to give me a non-trivial isomorphism. Right? So what if I wanted to look at phi1 of, sorry. What if I wanted to look at phi1 of 3? What would that be? What would that be? Well, what is 3? 3 is just 1 plus 1 plus 1, right? Cool. So we have phi 1 plus 1 plus 1. That's going to be equal to phi of 1 plus phi of 1 plus phi of 1. So that's equal to 3 plus 3 plus 3 is equal to 1. Does that make sense? Michael, does that make sense? Pedro, does that make sense?
Yeah.
Cool. So, so what would happen if I, instead of picking, mapping 1 to 1, 3, 5, or 7, I instead mapped 1 to 2? What would I get?
Is it the same problem?
Yeah, it's the same Z8.
You will get 6.
So I'm mapping phi 1 to 2. What am I kind of, is there something noteworthily different about what? So I have phi 1 is equal to 3, and then I'll have phi 4 of 1 is equal to 2. Is there something noteworthily different about this guy versus the other 3 phis that I defined?
Yeah, I don't think you'll get all the elements in Z8.
Exactly. It's not an isomorphism. So it's, and that has to do with the fact, remember I said earlier that I can map 1 to any generator. If I map any generator to any other generator, I'm going to get a non-trivial isomorphism from itself to itself. Or if I map any generator to any generator, I'll get an isomorphism. Just if I map 1 to 1, it's not a very interesting isomorphism. But this guy right here, it's still going to be it can still be a homomorphism if it follows the same rules of what is 5a plus b is equal to 5a plus phi of b. Right? Right? Someone give me the actual formal definition of an isomorphism.
Then it has to be like a bijections and also follow the homomorphism property.
Yeah. So it's just a bijective homomorphism, but obviously not all homomorphisms are bijective. So is there anything else that I should cover? So does anyone have any other questions that they want me to go over? I believe you guys are supposed to have a midterm, Justin. So I believe that according to your syllabus, there are supposed to be 7 homeworks, a midterm, and then like a 2-part final exam. But it looks like week 9 is your midterm, Pedro, you're saying? Okay. We're already, I think, not on track to be able to do I have no idea. I have not talked to the professor about how that's going to work. I don't know if that's just something that he imported from the previous times that he's taught this course in person, and or if it's something that he's kind of hammered out what he wants to do in terms of everything being online. So I'm not sure. I just looked at the syllabus earlier actually to see the number of homeworks and that the course is supposed to have, and it said 7. Considering we are, I believe, in week 5 right now, and you guys have only had the 2 homeworks, I don't think we are on pace to hit that. I've actually had a couple of courses that had oral finals, and they were a lot of fun. They're a lot more fun than the sitting down and taking a test if you feel comfortable just kind of having a conversation with the professor, but I kind of doubt that's what's going to happen. I wouldn't be opposed to it though. So, okay, yeah, week 6 makes a lot more sense for a midterm than week 9. But like I said, I'm not really sure what's going on. Who's teaching your PDE course? Also, I'm gonna stop recording.